Hello everyone, this is Mr. Kozlowski and welcome to Unit 3 Forces. This is learning target number 2, and today I'll be discussing Newton's third law of motion. Now if you're thinking to yourself, well, what happened to the first law of motion and the second law of motion? He just skipped right to 3. You are correct, I did skip the 3. We generally teach Newton's third law first because it's the easiest for students to grasp, and also it will help you understand the other laws as we progress into those. And you probably have some familiarity with this law, so that's why we start out with it first. So what is the learning target? Learning target 2 states that students will understand Newton's third law of force pairs, and it can apply that law to everyday occurrences in the world. You have probably heard the phrase that for every action, there's an equal and opposite reaction. This essentially is common language to describe Newton's third law of motion. Basically, Newton stated that laws act in pairs. So for every force that is acting upon an object, that force is then applied back to that object in the same force and opposite direction as the first initial force that is applied. So what does that mean? Well, take a look at this picture. We have a graphic of a cartoon pushing a wall here. So this person is pushing against the wall to the left as specific force. However, what the law states is that the wall is essentially pushing back on the human here with the same amount of force in the opposite direction. That would be the third law of force pairs acting. So basically, the person pushes on the wall is essentially, according to Newton's law, is pushing back on the person. So what is the technical definitions here? Newton's third law of motion states that 1. Forces are always going to act in pairs that are equal in strength and opposite in direction. So this means that the size of the forces on the first object equals the size of the force acting on the second object. It also means that the direction of the force on the first object is opposite to the direction of the force on the second object. So we've talked about this concept that forces work in pairs and they're generally equal and opposite when they're balanced, but we've only been discussing one object. Now we're going to discuss 2 objects. This technically is a system that we're going to be describing, so please understand that these problems are kind of larger and kind of big picture problems that you must understand in order to be proficient in this learning target. Examples of Newton's third law. If we have a bird that flies by using its wings, the wings of the birds are pushing down or push the air downwards. Since forces result from mutual interactions between these objects, the air must also be pushing the bird upwards as well. This is what causes the birds to fly. Second example, if we have the motion of a car on the way to school, the car is going to be equipped with wheels that spin. And these wheels come into contact with the road and they grip and push the road essentially backwards. Since the forces result from mutual interactions, or since they act in pairs, the road must also be pushing back on the wheels and push the wheels forward. That would be another example of Newton's third law of motion. There are many different examples and video examples that we can give to you, and actually I'll pull some of these up in class, but what I'm going to do for lecture is I'm going to provide these links in the comment box on YouTube. Please check these out. There may or may not be some quiz questions on some of these videos, so please check these out. I also have some timestamps there for you to check out specifically, and if you have any questions about these videos, please let me know. So the big thing is, once we understand the concept of third law pairs, third law force pairs, you have to be able to solve third law force problems. And what we have here is basically a continuation of what we're doing in learning target 1, which was to identify forces in a force diagram. And basically what we have here is an object. So let's use the example I used at the beginning of this lecture of person pushing on an object. So we have a graphic here of a person pushing this box here. So when we do a third law problem, you're going to do a step. The first step you're going to do is to draw a force diagram for each object in the picture above. So what I've done here is I've drawn a force diagram for the person, which is on the left, and I have a force diagram for the box, which is on the right. So this is going to be a little different in the fact that now you have to draw two force diagrams. You have to draw those, or you have to describe them. So when we describe the forces, again, you must talk about what that force is acting on and then what is causing that force to act. So for example, force applied on the person from the box. Well, essentially, this box is pushing the person to the left if we're looking at the person. If we look at this perspective from the box, right, and draw the force diagram for the box, well, we're going to have different forces here. So instead, now we have a force on the box from the person because the person is then pushing the box to the right in this picture. So again, essentially in the first step of third law problems, you have to draw force diagrams. So if you're not proficient at drawing these yet, please come see me because once we just start drawing two of these at the same time, it gets a little complicated. Step 2, we must calculate all the forces acting on each object, and we're going to use our force calculation, basically the force of gravity equation, to start that. Again, force of gravity is equal to the mass of the object times 9.8. Keep it simple, calculate gravity, determine if its opposite force is balanced or unbalanced, and describe it properly, either using numbers of the force that's given to you or the numbers of the force that you calculate. Sideways force is kind of the same thing. Usually in a problem we're going to give you that, so you should be proficient at already calculating forces. Finally, the last step is now that you have two, you must identify third law of force pairs. So according to the law, again, forces act in pairs. They are equal in strength generally, and they will be opposite in direction. So if we look at this force diagrams for the third law problems, if I say identify the third law of force pairs, well, the main one that we have here is force applied on the person from the box and force applied on the box from the person. So we have two force diagrams. Box is being pushed by the person and to the right. It is equal in strength and opposite in direction. If we look on the person's force diagram, now we have the force applied on the person from the box going to the left. So these would be the force pairs right here. Force applied on the person from the box, force applied on the box from the person. They are equal in strength, opposite in direction, and that's essentially what we want you to understand, that you have to understand the law, know the law, and use it and apply it to a situation like this and identify the force pairs. So, to review, very simply put, Newton's third law of motion. Forces are going to act in pairs. Those force pairs are going to be opposite in direction, and then they're going to be equal in magnitude or equal in strength. And we've talked about that before in class. The only difference, again, is that you have, in a problem, you're going to have two force diagrams that you have to draw out now. Finally, the last bullet point is that when we get to these problems, you need to describe and identify those force pairs both qualitatively and quantitatively. So qualitative, again, that's describing force of gravity on box from Earth. That's a qualitative description. Quantitative would be force of gravity is equal to 19.6 newtons. That would be the numerical value that you calculate for that force. So you have to know the force of gravity equation, which is equal to mass times 9.8. Please complete the quiz. Again, if you have any questions, please let me know. Take good notes, and we'll get a lot more practice with this in class. Thanks.